Emostel.
Hello, you're welcome to Emostel Academy, and this is Emmanuel Kadiri. In this class, I'm going to be teaching you on surds. So, a surd is defined as an irrational number that cannot be simplified to remove the square, or probably the cube root, or any kind of root, just the root that is on it. Okay, you cannot further remove it. There are things you can do to remove a root, right? For instance, now if you have the square root of 25, the square root of 25 is simply 5. Okay? So, and which is a rational number. All right? The square root of 144 is 12. Okay? And all of this. Okay? But a situation where we have root 2, you cannot further simplify root 2. You cannot break it down. You cannot do anything to it anymore. You just leave it as root 2. You can't do anything over it anymore. Root 3, the same thing. You can still break this one down, okay? But stuff like this cannot be further broken down. You just leave them that way. Do you understand? If it is root 25, you can break it down to become 5, because root 25 is like, yeah, and there is even a rule that's, I think I'm missing out here. All right, let me just add it here. Rule number 3, like rule number 3 is roots x, or let me say root m, multiplied by another rule, root m, is equal to m. It's not really a special rule. It can be explained with indices, but the rule is just that when the same roots multiply, okay, you are going to get just the ordinary number without the roots on it. We can use the law of indices to explain it. In laws of indices, we understand that the square root of m is the same thing as m raised to the power half. Okay, you remember that law in the video on indices, where we say the denominator will form a root while the numerator will form power. So m raised to the power half is simply like the square root of m, then this power, okay, 1. And I told you that when it's a square root, you don't need to put 2. Just put ordinary root. And then any number raised to the power 1 is the same thing as that number. So which goes back to this root m. Okay, so we understand the fact that root m is the same thing as m raised to the power half. So when we have m raised to the power half multiplying another m raised to the power half, that is the meaning of root m multiplying root m. So if you have it that way, then we are going to be having m raised to the power half plus half. According to the laws of indices, the powers will add up, and then we have a common base. And then in that case, you have half plus half is equal to 1. And according to the law of indices, any number raised to power 1 is that number. And so that's the reason why we have it that when the same roots multiply, we are going to get just the number under the roots, okay, as the result. So just understand that law, because we're going to apply it to solve a couple of questions very soon. All right, so as we have it this way, we get it that all of these are common examples of surds because they are irrational numbers. So anyone that comes in this way, any root or that comes in this way, that appears this way, that you cannot further break it down to remove the surd from it, the root from it, okay, it's called a surd. All right, so a surd is an irrational number. All of these are irrational because if you press their values in calculator, you will get long results. You are not going to get a definite fraction or a definite decimal. You're going to get a long decimal indefinitely. Do you understand that? So that is why they are rational. Okay, they are irrational rather. So a surd is an example of such. It's an irrational number that cannot be simplified. So in this stage, it's already irrational. And then another thing again is that you cannot even further simplify it to remove the square, or maybe the roots, like in this case, like the cube roots. Okay, you cannot do anything to it to further reduce it. It's just like that. You know, you can only leave it this way. So we said a surd is an irrational number that cannot be simplified to remove the square or the cube root or whatever root it is, that sign, and still give a rational number. You cannot remove it without and still get a rational number. You can't. Okay, So then, simply speaking, a surd is a root, like all these roots that you have in here, that does not give a whole number, okay? Unlike the root of 25, that will give you 5 as the answer and all of that. It's a root that cannot give a whole number and that cannot be simplified into a rational number, okay? So that is that as for that. So when you just notice that anything that appeared in this form, it cannot be further broken down, and even the direct result will still give you long decimal, then they are simply called surds. So this topic is dedicated to surds, to talking about how we can operate on surds, what we can do with them. Okay, so that is what all this topic of discussion is about. Okay, so how do we manage them? We manage surds with these rules. The rules are more than this. Okay, so I'm going to continue those other ones in part 2. But these are the basic rules, the fundamental rules that guide surds. Okay, so let's quickly go into those rules with examples. All right. If we have something like this, according to the first one, if you have something like 2 root 2 plus 3 root 2, as far as they are the same roots, okay, it's just as if you are saying 2x plus 3x. The same way this would give you 5x. It's just like $2 plus $3 will give you $5. So that is how 2 root 2 plus 3 root 2, in as much as they are identical, okay, then it's going to give you 5 root 2 as it is in this law. So it's just, or you can just say 2 plus 3, just like this law, then common root 2, which is simply 5 root 2. Or you can just go straight to the point. 2 root 2 plus 3 root 2 is 5 root 2, and then you're good to go. All right, so that is what this first law is talking about. And if it is subtraction, it goes the same way too. So if I have it this way, like 3 root 2 or 3 root 5 minus 2 root 5, the answer is going to be 3 minus 2 is actually 1. Then root 5, so it's just going to give us root 5. 1 root 5. And you know, when it comes to 1, it's invisible. You don't write it. You start to write stuff like that from 2 upward. So it's just as simple as you saying 3x minus 2x. So 3x minus 2x is going to give you 1x. But you don't write that 1. It's invisible. And so that is how it goes. I believe you get that clear. Okay, so then number 3, if you let's just have examples on this the product or the quotient. Product means multiplication, quotient means division. So, and then applying this law here too. Remember this law. So some of the questions that we're going to be dealing with here will need this this stuff. But let's just start it basically. Okay, if you have something like root 3 multiplied by root 4 is the same thing as a general root 3 times 4. You can do that for multiplication and division. You cannot do it for addition and subtraction when they are different roots. Okay, please mind you, if I had this one by saying maybe 2 root 2 plus 3 root 3, we cannot add. You just leave the answer this way and you stop there. Reason being that they are not identical surds. Okay, they are not identical. You can only add when they are identical. They are not the same, so you just leave the answer this way. There's nothing you can do about it at this stage. If you had added like maybe something like maybe 10 root 2 plus maybe 5 root 3, right? You could still do some mathematical stuff like factorization. You can still factorize and say, okay, we have a common factor, 5 can go, and say 5, and then you have 5 in 10 will give you 2. So you have 2 root 2 plus. Then 5 in 5 is 1. Then you have 3 in bracket like this. So you can still do stuff like this. You can still manage to do a few mathematical stunts, okay, by factorization and some other things. But you can't turn them into a single root if they are not identical. It's just like you saying 10x plus 5y. You cannot add $10 to 5 naira. It doesn't go. You can only add when the both of them are x or when the both of them are are y. Okay, so that is how it goes for addition and subtraction. This law of addition and subtraction is only applicable to a situation where the roots are identical. Do you understand? So that is that where the surds are identical. Okay, all right. So as we have it this way, 3 times 4 is going to give us 12. So we have root 12. This is officially allowed, very much allowed. Okay, so but in this question, okay, let me just use something that is like irrational. Let me use an irrational example. So 3 times 7 is 21. Okay, so because root 4 is not a surd, because you can still rationalize it. The square root of 4 is 2. So you have just put 2 there, and then 2 multiplying this would have given you 2 root 3. So, okay, let me give you as an example 3. If I had added as root 3 times root 4, I would have preferred to say root 3, since the square root of 4 is rational. Okay, so you can just say the square root of 4 is 2. So root 3 times 2 will give you what? 2 root 3. Okay, it's just as if you said x times 2 will give you 2x. So on a similar note, root 3 times 2 will give you 2 root 3. And so that goes thus. Okay, so that is for multiplication. You can still divide. Okay, you can say 5, let's say roots root 10, okay, divided by root 5. Root 10 divided by root 5, okay, is still the same thing as saying root 10, or you can rewrite it as root 10 divided by root 5, and then you can put it as a general root 10 divided by, 5, and so root 10 divided by root 5, or 10, or this general square root of, or general root of 10 divided by 5 would give you root 2. And so that is that. So all of these laws are good. Okay? You can apply them. And then, but when you have some kind of special questions, some kind of very intelligent questions, question that really want to play with your brain a little bit, then you might need to start mixing all of these laws to simplify them. All right, so let's just quickly check out some few questions that have to do with simplifying surds, and then you see us making use of all these laws, whichever one is applicable, to just break it down and arrive at the answer. Okay, we have all this set of questions now to play with, just to explain all of this, and we'll move on. Okay, starting with the first one, the square root of 50, we just want to simplify it, want to break it down to something simpler. We know quite all right that this is irrational. We know quite all right, okay? So, but then we want to break it down into something simpler and stop there, something more portable. So that's what we want to do. So now, having root 50, we can just break it down into something like, using this law of multiplication, we can reverse the law. We can reverse it from like something of this form into something like this, just the backward. Okay, so we have root 50. We can make it to be like root 25 times 2, all right, so that we can have something of this nature. Then we now split it into these points by making it like root 25 multiplied by root 2. Now, root 25 is not a surd, it is actually rational. So root 25 can give us 5, because the square root of 25 is 5. 5 is the number that multiplies itself twice to give us 25. So, which means the square root of 25 is 5. So, we have 5, then multiplied by root 2. Okay? And then finally, we see that root 50 is simplified as 5 root 2. And that is it. Simple and okay. So we can still apply the same process to solve this root 72. So root 72 would be like root 72 is equal to, you just, and then, again, if you are confused about the number, okay, you don't know what you can break it down into that can make it simpler. I have a method of approach. So you can just have this root 72, this 72, and start dividing it from a small number like 2. Okay, if 2 cannot be divided, you move up to 3. But just start with 2, 3, just all those prime numbers. Okay, prime numbers 2, 3, 7, 2, 3, 5, then 7. So just use all those numbers to try and divide this thing, and then to break them down so that I can collect all those prime factors. Okay, so 2 is the first prime number in mathematics. So we have 2. A prime number is a number um, that cannot be divided by another number apart from 1 without giving a remainder. Any number you use to divide a prime number will always give you a remainder, except if that prime number divides itself or it is being divided by 1. You get that? So 3 is a prime number because no number in the world can divide 3 without giving you a remainder or a decimal. Okay? 5 is a prime number, and 7 is a prime number, 11 is a prime number. They don't have anything that can divide them that won't give you a remainder. 8 is not a prime number because 2 can divide 8. 9 is not a prime number, 3 can divide 9. You understand? 10 is not a prime number, 2 can divide 10, 5 can divide 10, but 11 is the next prime number after 7, then 13 is the next, and so on and so forth. So use prime numbers to divide anything you have here, okay, so that I can break it down. So 2 goes in 72, like 2 in 7 will give us 3, 2 can go in 7 3 times, then remains 1. So that attach that 1 to 12, so that will give you 6. So 2 goes in 36, that will give you 2 in 3 is 1, remaining 1, right? So 2 can go in 3 ones, remain 1. Then with that 1 attach it to 16 to make it add that's 10, it's like 10, but that's 16. So I don't want to go down that explanation, but yes, just pick it up as 1, then attach to 6, making 16. 2 in 16 will give you 8. Okay, good. So 2 again goes. 2 in 18 is 9. Then at this point, 2 can no longer divide, but we now move to the next prime number, which is 3. Now, 3 divides 9 to give us 3, then 3 in 3 is 1. So as you have it here now, it means that root 72 is as good as breaking it down to something like root 2 times 2 times 2 times 3 times 3. You get that? And then that is where stuff like this will come in place, because it's more like you're saying root 2 times root 2 times root 2 times root 3 times root 3. Okay? Now, every 2 roots will multiply to give you the number under it. So 2 surds like this, 2 identical surds will multiply to give you just 2, normal 2. All right? Then 2 identical surds here too will multiply to give you normal 3. So it's as if you're saying 2 root 2 times 3. Then this 2 times 3 will give you 6. So finally, the answer is 6 root 2. 6 root 2. So, but if you can really easily break down, you know the 2 numbers that can multiply 72 that will give you irrational numbers, you can just go ahead straight up. You will still get the same answer. For instance, you could break 72 into something like 4 multiplied by 2 times 3 times 3 is 9, 9 times 2 is 18. So you can multiply, you can break it down into 4 times 18. But instead of you just thinking of big numbers like that, this is just a perfect solution to that kind of problem. But if I was the one solving this, or if I was in an examination, I was just trying to solve this, and after breaking this thing down in this way, I would just group them. This is 1. So 2, 2 will give me ordinary 2. 3, 3 will give me ordinary 3. So I'll just say 3 times 2 is 6. Then this one is standing alone. I will say 6 root 2, because I will just assume that there is a root over each of them. then all I just do is to pair them. Pair these two to give you normal 2. Like, you just assume this is root 2 times root 2. Okay, right from here. Okay, so if you're just trying to, if you're attempting this as an exam question, you may not need to start writing all of these things. The moment you just do this rough work in one corner of your script, then pair these guys, okay, pair them. 2, 2 gives you a single 2, 3, 3 gives you a single 3, just based on this law, okay? Then 2 times 3 will give you 6. This one that does not have a mate, you just write it out as there is 2, and then you are good to go. You see that? So the answer to that root 72 is simply 6 root 2. So that's what you do when you don't know, when you can't break it down to easy ones like this. This one is just easy and straightforward. You know that 50 is 25 times 2, and then you know that 25 is rational. So 25 being rational will give you, the root of 25 give you 5. And like, but in this case now, you might just be having a tough time trying to figure out what to break it down into, like you did here. So if you have that kind of situation, just use this method and then you're perfect. Pick it up from here and then you jump to the answer. That's all. You get that? Good. So we quickly move on to the third question. All right. So the third question says root 75 plus root 12. Root 75 plus root 12. We're dealing with the third one now. So we are done with this, we are done with this. Okay. Now to solve this one too, you just apply the same method. You can break it down. If you know the things that can multiply to give you 75 and that can give you a sort of rational and irrational sort, please go ahead. If you don't know, use that method I just taught you. Okay, so like I just want you to be very familiar with the method, so I will choose to use that method, okay, to simplify 75 and 12. So I can just say this is 75, and then you have it this way. So you cannot use 2. 2 cannot divide 75 without remainder. Okay, so you try 3. If 3 can do it, then you use 3. Make sure you use the smallest prime number first, then you now advance into the bigger ones. Okay, so 3 can go here. 3 can divide 7 2 times, right? It will remain 1 because that's 2 times means 6. Then it remains 1. So that's 1, attach it. This one becomes 15. 3 goes in 15 how many times? That's 5 times. 3 times 5 is 15. Now you cannot use 3 anymore because 3 cannot go in 25 without remainder. So you move to the next prime number, which is 5. Now 5 divided by 25 is 5. Then you kill it again. Then until you keep dividing it until it remains 1, until it gets to 1, in which you cannot further divide anymore. Okay, so if you have it that way, you stop there. Now check this one out. For root 12, just have it as this 12. The smallest prime number that can go in 12 is 6. Then 2 again goes, 2 and 6 is 3. 2 cannot divide anymore, so you jump to the next prime number, which is 3. 3 and 3 is 1. Now that you have gotten to the last stage, then you pair them, okay? 5 and 5 will give you a single 5. Okay, so we are having something like 5 root 3 now, because this one cannot go. Remember that you can put it as roots. Root 3 times root 5 times root 5. Okay, this root 5 times root 5 will give you a single root 5 according to this third law here. Okay, then multiply by what? Root 3. So we have root 5 root 3, right? So simply speaking, any one that does not have a pair will remain standalone. But the ones that can be paired, you pair them and then you multiply. Okay, this one and this one now, they are pairs. So you can just, it will give you a single 2. So from this first one, we have 5 root 3, because we have these 3 standalone, 5 root 3. Then from this second one, okay, this addition, you break it down. Then from this second one, we have 2, okay, root 3. All right. So then 5 root 3 plus 2 root 3, according to the first law here, is going to give you 5 plus 2, which is 7. So the answer is 7 root 3, and then you are good to go. All right. So it's easier when you break them down into prime factors, and then when you get the prime factors, look for the pairs. because the prime factor is just as if you are still writing the real one, but in broken form. So which means that root 75 ideally is actually can be written as root 3 times 5 times 5, or broken down into root 3 times root 5 times root 5. Okay, according to this product law here, the overall umbrella can be broken down into individual stuff, and then you just have it root 5 times root 5. According to this law, we give you ordinary 5. So you have root 3 multiplied by 5, and that is going to give you 3 root 5. 5 root 3, and so. Okay, so that's how we got this one. But if you don't want to go through all of this, you can just jump straight from this stuff. Okay, pair them 5 5, pair it into a single 5. Excuse me. Just as you have this one like this, pair it right from here. Instead of spending time breaking it down here, pair it from here. Then the 3 standing alone without any pair, you write it out as root 3, then multiply, and then you get it off. Pair this one too. Likewise, gives you a single 2, then 2 root 3, because this one is standing alone without a pair. All right. So that's just the fastest way to get it done. And so that is the end of this number 3. We are done with this. So let's quickly solve number 4. If I'm too fast, please, you can slow down the video, go to the settings, press the setting button. You will see that X, you see 2X to make it faster, and then you see 0.5X or whatever, or like that to reduce it, to make it slower. Okay. All right, good. So let's quickly go to the 4th one. We have, all right, so in this question precisely, that's 3 root 18 minus 2 root 8. This one is quite easier. All right, so quite easier in the sense that you can, now 18 can simply be broken down into 9 times 2, while this one can easily be broken down into 4 times 2. All right, so so we have 3 root 9 times root 2 minus 2 root 4 times, okay, so let's say 3 times, let's assume you're breaking it down like that too. So 3 times root 4 times root 2. So root 9 is rational, root 4 rational. Okay, so this is not a surd, this is just a normal root. So because you can break them down. So you have 3 multiplied by root 9 is the same thing as 3, because you can say root 9 is root 3 times another root 3, and then it will give you ordinary 3. So then, or you can just say the square root of 9 is 3, obviously. Then root 2 minus 2, you have 2 here for root 4. The square root of 4 is 2, then root 2. So at the end, 3 times 3 is 9. So you have 9 root 2 minus 2 times 2 is 4 root 2. So 9 root 2 minus 4 root 2, now they are identical. So you can just subtract. So 9 minus 4 is 5. So you have 5 root 2, and that is the final answer. Okay? So now, on the similar notes, we can just break this one down, like question number 5. Question number 5 is root 50 plus root 32 minus root 18. These ones two are simple and straightforward. You can break down root 50 to become something like 25 times 2, plus root 32 can be broken into like 16 times 2. And then this one can be broken into root 9 times 2. So as you have it this way, you can just break it down to root 25 times root 2 plus root 16 times root 2 minus root 9 times root 2. So root 25 is 5. Multiplied by root 2, that gives you 5 root 2, plus this one gives you 4 root 2, minus this gives you 3 root 2. That's the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. Then with it root 2. So we have 5 root 2 plus 4 root 2. That's 5. Since they're all identical, you can just carry out the addition or subtraction. So we have 5 plus 4, that's 9. 9 root 2 minus 3 root 2. So that gives you 6 root 2. And that is that for that, okay? So quickly, we are done with 4, we are done with 5. So let's just play with question 6 and 7. Then we call it a day. So question number 6, it says root 45 divided by 3 plus root 20 divided by 2. Okay, so to solve this question, you can break root 45 into a factor of a 9 factor, right? So that will be 9 times 5. And then this one too can be broken into 4 times 5. So we have root 45 broken down as 9 times 5, okay, divided by 3 plus root 20. Root 20 is broken down into 4 times 5, then over 2. All right, so root 9 times root 5 over 3. So we split this one as well as root 4 times root 5 over 2. Okay, so the square root of 9 is 3. So we have 3 root 5 divided by 3 plus 2 times root 5. You know the square root of 4 is 2. So 2 times root 5 divided by 2. Okay, and so you can divide on each side. Okay, you cannot divide across addition. You cannot say this one cancels it, but since they are on the same fraction, so you can carry out the division. So 3 divided by 3, so you have root 5 here, pardon my marker, then 2 cancels 2. Okay, 2 divides 2, then you have plus another root 5. Okay, so here we are having 1 root 5 plus another 1 root 5. Final answer is 2 root 5. And that is the end of that question. Okay, so we are done with question number 6. Now we move to question number 7. We move to question number 7. To solve question number 7, we can have let's just have we have root 8 multiplied by root 18. So root 8 can be broken down as the root square root of 4 times 2. Root 18 the square root of 9 times 2. And then we have this one as root 4 times root 2 multiplied by root 9 times root 2. And then we have this root 4 is 2 multiplied by root 2 times root 9, which is 3 multiplied by root 2. Okay, so 2 times 3 gives us 6. Root 2 times root 2 gives us ordinary 2. And then this is 12. You can further simplify this one. We can just go directly from the beginning here by saying root 8 multiplied by root 18. 8 times 18 is 144. So if 8 times 18 is 144, the square root of 144 is 12. So you could still go directly that way and get the answer. So, right, it's been an interesting class so far, and I feel that you've learned a lot. So if you have any question whatsoever, please just register with us, and then we'll be able to answer you. You find this link for the registration down below this video. And then also, if you love this video, please punch that like button, and it makes you to be able to get more of this video. All right, and then if you have not subscribed to our channel before, please hit the subscribe button and then put the notification to all, so that all of our videos that we drop You see them as we drop them hot. And then also, please, I want you to just share this video to as many people as possible, or as many as this video will be useful to. And then we see you again in part 2 of the laws of Surds. Bye.